Okay, this is the exam 3 review. Okay. And I'm just going to go through each of the questions with you. If you still have questions after this video, feel free to send me a message via remind or email, and we can talk about setting up a time to discuss one more in detail. So number one, that's the total area under the normal curve, and the area under a normal curve is always 1. And then on number 2, determine whether the graph shown could represent a variable with a normal distribution. Well, if I'm looking at this, that's my problem right there. Okay, when we have a normal distribution, it doesn't go below the x-axis. So this should be C. The graph could not represent a variable with a normal distribution because the curve crosses the x-axis. Okay, and I just printed out your math lab so that you can see my questions. So I have a book because it also printed out all these little tables. But next question, number 3, find the area of the indicated region under the standard normal curve. So this is my keyword here, a normal curve. So that tells me I'm going to do normal CDF. Okay. And when you do the normal CDF, that is on your calculator under second bars and then number 2. Okay. Now it's asking me for a lower and upper bound, and then it's asking me for the mean and the standard deviation. Okay, well, my lower bound here is negative 1.1. My upper bound is 0.9. This has a mean of 0 and a standard deviation of 1. Okay, so that's what it looks like in parentheses. Okay, so you should end up with, and this one says round to 4 places, so it's 0.6803. So I did not use my table, I used my calculator instead. Okay, moving on to number 4. As standardized exam scores are normally distributed, okay, so there's a keyword there. It's telling me the mean test score is 1454, so that's my mean. The standard deviation is 318, that's my standard deviation. The test scores of 4 students selected at random, and it says find the z-scores. So my formula for the z-score is to take x minus the mean and divide by the standard deviation. So my x on this first one is 1900. When I subtract my mean of 1454, and then I'm going to divide by my standard deviation of 318. Okay, that gives me a fraction. It wants me to round to 2 decimal places, so I go to math and I change it to a decimal. Okay, your calculator may tell you a decimal to start with. I just have mine set up to always give me fractions, so that's why I had to do that last step. Okay, then we'll basically do the same thing except change 1900 to 1190. So that's going to be negative 0.83. And then change 1190 to 2180. And finally change 1330, or change to 1330. And that's negative 0.39. Okay, which values, if any, are unusual? I'm going to say this one here because my z-score was more than 2. Okay, so that means it was more than 2 standard deviations from the mean. So my unusual values are, let's see here, if it wants I think it was the z-score. Yeah, 2180, or not the z-score, the actual number. So 2180 is the unusual value right there. Okay, moving on to number 5. Okay, find the probability of Z occurring in the indicated region. So we want the probability that Z is between 0 and 1.29. So this is a standard normal distribution again. So I'm going to do normal CDF. My lower bound is 0. My upper bound is 1.29. Still a mean of 0 and a standard deviation of 1. And so this time when I round to 4 places, I have 0.4015. Moving on to 6. Same kind of problem, except this time you have a different mean and standard deviation. So I can kind of take a shortcut and just copy that and go back and put 70 31st, delete that 0, then put 79, and then instead of 0, I have 89, and my standard deviation is 5. And once again, we round to 4 places, so it's 0.0221. Okay, the first one, this one's asking me for the probability that it is going to be less than 19. So when I look at my normal CDF, because once again, this says it's a normal distribution. There we go, scroll it down a little bit. Okay, this time if it's just less than 19, I do not have a lower limit. So you can either type in negative 10,000 or it defaults negative 1E99. Okay, I already had something typed in there, so that's why I didn't do that. My upper is 19 because I'm less than 19. My mean is 20.3 and my standard deviation is 5.4. Okay, that's what it would look like if you just copied from that last one and changed numbers. But either way, you end up with, and this one's a percent, so 40.49% when you round that to 2 places. And then on this next one, when we say the probability that it's going to be greater than 21, then this time I do not have a upper limit. So when I go to, and I can either copy this or go back to the original, but basically my lower this time is 20 and my upper is negative 10,000 or however many zeros you want to put there. I don't have to change 20.3 or 5.4 because this is the same problem. Oh, and I see what I did wrong right there. My upper limit cannot be negative, can it? That's a lower limit. So take out that negative. Okay, and that gives me my probability or my area, but we want to know out of 1,500. So if I multiply that by 1,500, then I end up with 673 when you round it to the nearest whole number. So I just multiplied my probability times the 1,500. Okay, number 8, when we're finding that z-score, remember when we're finding our area, it's always to the left of the graph. So when we have something to the right, I need to take 1 minus 0.0239 to figure out what the area to the left would be. So the area to the left is 0.9761. That's that part. So if I'm going to find my z-score, this time I'm going to do the inverse operation. So I go to second vars, and I'm finding, I know the area because the area is 0.9761 from here. My mean and standard deviation are 0 and 1. So when I look at my z-score and I round 2 places, that's going to be 1.98. Number 9, on this percentile being 65, you are going to use the same inverse operation. Let me write on 8 that that's what we did. If you're going to use your calculator instead of the table, you're going to say your area is 0.65, and then your mean and standard deviation are still 0 and 1. So I can just copy that and come over here and put a 0.65, and that gives me 39. Okay, that 65 percentile is 65%, so that's 0.65. That's where that came from. Okay, so that was using our calculator. We don't need the table again. And we're on to 10. Okay, on number 10, we have, first of all, the mean is 5.1, so that's our mean. The standard deviation of 0.3 is here. What's the minimum red blood cell count that can be in the top 22%? So if it's the top 22%, that means it's going to be the bottom 78%. So when I look at the inverse norm, so it's basically asking me the same thing as the last two problems. Your area this time is going to be 0.78. Okay, but this time instead of a mean of 0 and a standard deviation of 1, I have a mean of 5.1 and a standard deviation of 0.3. So that gives me 5.33. Then on B, what's the maximum red blood cell count that can be in the bottom 13%? So since that's the bottom, I already have my area. So I'm just going to change this to 0.13 for my 13%. I still use the same standard deviation and the same mean because it's the same problem. So 4.76 on that. And that was number 10. Okay, on 11, determine whether the statement is true or false. Well, let me roll it down here to where you can see it. There we go. If the size of a sample is at least 30, you can use z-scores to determine the probability that a sample mean falls in a given interval of the sampling distribution. That is going to be true. Okay, because that was part of our rule. We had to say n was greater than or equal to 30. Or it had to be normally distributed. So if your sample size is greater than or equal to 30, you're good to go. Okay, number 12, we've got a mean of 142, a standard deviation of 28. We want to find the mean and standard deviation of the distribution of the sample means with the sample size of n equals 46. So your mean of the sample means is always the same, so it's still 142. Okay, but then your formula for the standard deviation of the sample means is the standard deviation divided by the square root of n. So I'm going to take 28 and divide by the square root of 46. And this is around 3 decimal places, so 4.128. Okay, then 13. For a sample of n equals 65, find the probability of the sample mean being greater than 227 if the population, the population mean is 226 and the standard deviation is 3.4. And then we know n is 65. Yeah. So on this one, we want to find the probability that it's greater than 227. So I'm going to go to second bars and go down to my normal CDF again. This time, if it's greater than 227, 227 is my lower limit. My upper limit, there's not one because it's greater than. So I put in 10,000 or use the default, whatever. I think I got 100,000, doesn't really matter. Your mean is 226. Your standard deviation is 3.4. But that is just the standard deviation. I need to divide it by my sample size of 65. So the square root is 65. And look, I can just put that here. There you go, you can see it better. I don't have to calculate it and come back and put it in. So you should end up with 0.0089. So round to 4 decimal places. Would the given sample be considered unusual? It would, because it does not lie within 2 standard deviations of the mean. Okay, number 14. Use the central limit theorem to find the mean and standard error of the mean. So we've got a mean of 112 pounds. The standard deviation is 37.9 and the random sample size of 18. So we said earlier our mean is the same for our samples. Our mean of our sample means is 112. And then our standard deviation of the sample means is going to be 37.9 divided by the square root of n. And this one wants the 3 decimal places, so 8.933. So when I pick out my graph, I want the one where my mean is 112. So that's either here or here. Remember, your mean goes right down the middle there. Okay. So one standard deviation of 8.9. Well, if I add my mean to that, the first one would be 120. 2 standard deviations would be at 129. Well, the way this looks, that looks like the third standard deviation is 129. Okay, the third standard deviation here is 138.8. So yeah, it's 8 because that 138.8 is on the third mark. So that's the third standard deviation. Okay, going on to 15. Okay, my mean is 64.1. My standard deviation is 2.9. And first of all, we want to know the probability of selecting one woman with a height less than 64.9. All right, so I'm going to do normal CDF. My lower bound, since it's less than 64.9, the lower bound is unlimited. My upper bound is 64.9. My mean is 64.1, and my standard deviation is 2.9. Okay, that gives me a probability of 0.6087. Okay, the difference in that problem and this one now says our sample is 22 women. So basically I'm going to take this, but that last number is divided by the square root of 22 because it's my standard deviation divided by the square root of n. So a little shortcut there would just be to copy that and then add that on at the end. That gives me 0.9022. So which one's more likely? Well, that has the higher probability. Okay. So you're going to say it is more likely to select a sample of 22 women with a mean height less than 64 because the sample of 22 has a higher probability. Moving on to 16. Okay, so when we're doing the continuity correction, this is where we have to add or subtract a half of a unit. So if it's saying that x is greater than or equal to 100, that means that 100 is included. And so that's going to be that one. I'm just going to draw a line to match them. Okay, on 6, p is less than 100. Okay, that means 100 is not included. So that's going to be p is less than 99.5. Okay, on number 7, 100 is included again. So it's going to be less than 100.5. And then p is greater than 100. 100 is not included. So in order for 100 to not be included, you would need to start at 100.5. So I just drew a line to match those, but you will actually drag them. Okay. Okay, on 17, this right here is basically telling me my p is 0.09. So that's going to make q 0.91. So if I look at NP, I need to take, there's my N, 600. And NQ would be 600 times 0.91. So if this is 54, that's going to be more than 5, and this would be more than 5 as well. Okay, so this one is going to be B, yes, both NP and NQ are greater than or equal to 5. Okay, find the probability that the number of people who say auto racing is their favorite sport is at most 63. So that means it's going to be less than or equal to 63. So if it's less than or equal to 63, that's going to be the probability that X is less than 63.5. So when I look at my normal, okay, if you're less than 63.5, your lower limit is unbounded, and then your upper is 63.5. There we go. My mean, what does it say about the mean up here? We have our mean formula, don't we? So the mean is N times P, which is going to be 54. And then our standard deviation is the square root of N times P times Q. So that's going to be the square root of 54 times 0.91. Okay, and you can actually put that in here. You can just say, you've already figured that out when we did NP, so that's 54. But then on this one, we've got the square root of 54 times 0.91. So on A, we have 0.9123 when we round to 4 places. Now, which one looks like it's shaded less than 63.5? That's going to be A. And then on B, when we're finding the probability that it's more than 67, that's going to be X is greater than 67.5. So this time, your lower limit is 67.5, and your upper limit is unbounded. Okay, I can leave those the same, but that gives me 0.0271. And my graph for that, greater than 67.5, would be here, shaded to the right because it's greater than. Okay, find the probability that the number of people who say auto racing is their favorite sport is between 49 and 57. So that's going to be the probability that X is between 48.5 and 57.5. So my lower limit is 48.5. My upper limit is 57.5. I keep all that the same. We're on the same problem. And so I end up with 0.4749. And there's the one where it's between two numbers. Okay, any unusual events? Well, if I go back and look at my 3 boxes, the only one that's less than 0.05 is here at B. So the event in part B is unusual because its probability is less than 0.05. Okay, on 18. Okay, this one was a little confusing because you have 2 different percentages, but I'm going to use that 70% for my P, making Q 0.30. So when I check NP and NQ, I'm going to have 200 times 0.7, which gives me 140. That's greater than or equal to 5, and that's also my mean. If I take 200 times 0.3, That's going to be 60. That's also greater than or equal to 5. So this is possible. Now I just need to find my standard deviation. That's going to be the square root of 140 times 0.3. Okay, then I go back to my 40%. You find that 40% say no. So if 40% are no, then 60% are yes. So if I take 200 and multiply it by 0.6, that gives me 120. So basically what this is asking me to do is find the probability that X is 120. So when I apply my continuity correction, I'm going to be saying P is between 19.5 and, or no, 119.5 and 120.5. All right, so then the glare off of that, there we go. My lower limit is 119.5. My upper limit is 120.5. My mean is 140, and my standard deviation is the square root of 140 times 0.3. Okay, that gives me 0.5307, but look right here, that e to the negative 4 actually means that I have 0.0005. So I'm going to choose B. The result is highly unlikely because its probability 0.005 is less than 0.05, and 0.05 is our level that we check to see if it's highly unlikely. So if it's less than that, it's definitely highly unlikely. So that means that the sample is not a good representative sample. Okay, number 19. For the sample statistics, which level of confidence would produce the widest confidence interval? Okay, the higher the confidence level, the wider the gap. So it should be this one. When it's 99%, because the level of confidence increases, then your z-score also increases. So that's going to make a wider gap. Okay, number 20, when you are looking for the z-score, when you know C is 0.91, that actually was a number not on our chart. So Google was my friend here because we didn't really go over the formula for finding that. Outside of the ones that are on your chart. Okay, 21, find the margin of error when you're given these values. So your formula for margin of error is to take your z-score and you're going to multiply that by your standard deviation over the square root of your sample size. So 90%, and this one has a table, so you'll just look that up. So 1.645. Your standard deviation is 3.8, and n is 49, so square root of 49. When you put that in your calculator, you should end up with 0.893, because we rounded to 3 decimal places. On 22, your formula for the sample size is to take your z-score and multiply it by your standard deviation and divide by your margin of error, and then you square that. So 99%, my z-score is 2.575. My standard deviation is 10.8, and my margin of error is 1 because it wants it to be within 1 unit. And then I square that. Remember, on this one, you're always going to round up. So 773 point whatever rounds up to 774. Okay, take a second to read 23. First thing we need to do is find our sample size. So our z-score for 95% is 1.96. The standard deviation here is 3.01. And then my E, well, it says it wants it within 0.73, so that's going to be E there. So that should round up to 66. And then for my confidence interval, I'm going to go to stat and tests and do my z interval. Okay, that is 3.01. My X bar on B is 28. My N is my sample size, so it should be 66. C is 0.95. I went right through it, didn't I? There we go. Okay, and this one says to round, what do I say? So we're going to do 27.274 and 28.726. Okay, so now I need to check my 3% and my 0.3%. So if I take 3%, so that's going to be taking 0.03 times my mean, which was 28. That's 0.84. So that gives me an interval of 28.84 on the right side. And 27.16 on the left. Okay, well, if I look at this, this is entirely inside of this. So that means that it seems likely that the population mean could be within 3% of the sample mean because the interval formed by the values 3% away from the sample mean entirely contains the confidence interval. Okay, now when I do 0.3%, that's going to mean 0.003 times 28. So that's going to give me an interval up to 28.084. So if I take 28 and subtract 0.084, then I have 27.916. So now if I look at this, it is not inside of this. Okay. So it is unlikely, it does not seem likely that the population mean could be entire this, because from a sample mean, you're going to say it overlaps. But doesn't contain. Okay. Now, those are going to be drop downs for you. That's why I was looking to see what my wording was exactly. There it is, way over here. But on yours, going to be a drop down. It always shows mine after the table, and this table's taking up 2 pages. All right, moving on to 24. Find the margin of error. So my formula for E, and this time we're talking about a t distribution from right here. So my formula for E is TC and then times S over the square root of n. So when I look at my t distribution table, I'm going to look up and then let's see, what was C was 0.98, S is 2.9, N is 13, so this means the degrees of freedom is 12 because it's one less. So I'm going to look up 12 and then I'm going to look up 0.98. So 12 and 0.98 is here, 2.681. So I'm going to take 2.861 and multiply it by my S, which is 2.9, divided by the square root of n, which is 13. And so that's just round to one place, so 2.3. Did I write that down right, 2.861, or is it 2.681? I love it when I transpose numbers. Let's see. 2.681, yep. So this should actually be 2.2 because that was supposed to be 2.681. There we go, 2.2. Okay, moving on to 25. Margin of error again. My S is 227. My N is the square root of 8. Now I need my T value. Well, C is 0.99. This is N, so the degrees of freedom would be 7. So I'm going to look up 7 and 0.99. 0.97 and 0.99, so 3.499. Okay, when you multiply that out, you'll end up with 280.8. And so when we do our confidence interval, go to stats, over to test, and we're doing a t-interval this time since we used our t-scores. So X bar is 515.5. My standard deviation is 227. My N was 8. And my C is 0.99. So 234.6 and 796.4. So when you interpret the results, it's going to be D with 99% confidence. It can be said that the population mean full retail price of cell phones and dollars is between the intervals endpoints. Oh, in this little space here, there are my choices there. The 280.8. It should be dollars. Definitely not square dollars. Okay. All right, moving on to 26. Okay, so this is 6.4. We've got the P hat and the Q hat. So why is it necessary to check those? And that is, A, it's necessary to check because if either values are less than 5, then the distribution may not be normally distributed. And then your z-score cannot be used to calculate the confidence interval. 27. Okay, this one's given me a C value of 0.9, and that one's for C value of 0.95. Okay, your N actually, this is going to be when you go to test, test, this is A because it's saying population proportion. Okay, my X is 700. My N is 2,000. Okay, because 700 said yes out of 2,000. My C is 0.9 for this first one. And so when I calculate my interval, it says to go 3 places, so 0.332 and 0.368. And then for 95, do the same thing, go down to A. Oh, y'all couldn't see that, could you? There we go. It's population proportion, that's why I'm choosing this. So this time I'll leave X and N and C is 0.95. So this one's going to be 0.329 and 0.371. Okay, with the given confidence, it can be said that the population proportion must be between the endpoints of the given confidence level. Compare the widths. Okay, the 95% is wider, like we said earlier. The higher the confidence, the higher the C-value, the greater the width. And then now we're ready to look at 28. Does a population have to be normally distributed in order to use the chi-squared distribution? The answer to that is yes. And then on 29, we want to find the chi values for the right and the left. So when I think of the value under the curve as being 0.9, that leaves 0.1 left. So I'm going to have to find 0.9 plus 0.05 and then 0.05 in my chart. Okay, so if 0.1's left, I split that between these two parts. Half of 0.1 is 0.05, so that's where those two came from. So when I look at my chart, did they give me a chart? They did not. So you are going to go to your slide. Let me see if I can find it on here and I'll show you. What I've got. Okay, so I put the chart on the last slide so that you don't have to look for the table in your book. So the last slide for 6.4 has the chart. Let me switch from my camera to my screen. Okay, basically this one is 0.95 and this one is 0.05. And my N is 16, that means my degrees of freedom is 15. So I'm going to be looking at 15 with 0.95 and then 15 with 0.05. Okay, here's the chart. So there's 15. 0.95 is 7.261, and then 0.05 at 15 is 24.996. So that one is going to be the right one, and this one is going to be the left one. So let me get off the chart here and come back to my camera. And those are my answers there. All right, last problem. Okay, so my N is 20. That's going to make my DF 19. And I'm looking at 95%. So that leaves 5% to be split. So one is going to be 0.95 plus 0.025, and the other is going to be 0.025. So when I add that up, I end up with 0.975. So when I look at my chart, I'm going to be looking at 19 with 0.975, and I'm going to be looking at 19 with 0.025. So I'll show you that again. Okay, 19 is a white line, 0.975 is 8.907. And then for 0.025, that's 32.852. So this one's my right and my left. So let me go back to my camera so you can see what I just wrote down there. Okay, now to find our confidence interval, we need to find our left and right endpoint. So my left endpoint, my formula says to take my DF, which in this case is 19, I multiply it by my standard deviation, which is 3.5, and I divide it by 8.907. Oh, and that was supposed to be squared. There we go. Then for my right endpoint, I take 19 times 3.5 squared, and this time I divide by 32.852. So that's 26.1. And that's 7.08. And that was supposed to be one place, wouldn't it? So 7.1. So I'm going to put 7.1 to 26.1. And this is for the variance. So when I get down to this one, I just need to take the square root. So I'm going to go ahead and do that before I forget. And I can just copy that. That's going to be 2.7 and 5.1. Okay, so with 95% confidence, you can say that the population variance is between 7.1 and 26.1. And then with 95% confidence, you can say it's, no, not greater than, it's this one, it's between 2.7 and 5.1. Okay, that gets us through all the review questions. Let me know if you need any help with any.